Hello. In this final video, we're going to put everything together when discussing solving trig equations. So just to start, I want to recap something like this. We have 3 sine x plus 0.8 equals 0. We want to solve on the interval 0 to 360, and we're going to need to use a calculator because I don't think this is going to give us a nice unit circle value. So the first thing we'll do is we'll subtract 0.8 from both sides. That'll give me 3 sine x equals negative 0.8. Divide by 3. So sine x equals... Now again, we want to be careful that we don't end up with weird decimals. So on a calculator, I think 0.8 divided by 3 will be 0.2666 repeating. But if you type it in on your calculator, it'll also give you the exact fraction. This is negative 4 over 15. And we want to leave it like that because we don't want any kind of rounding issues. Now we're going to go ahead and use sine inverse. And again, we drop the negative sign, so we just do sine inverse of 4 over 15. Make sure your calculator is set to degrees. And you should get 15.466 degrees. That's going to be your reference angle. And so again, using the cast rule, we're looking for a negative value, so that's going to be down here and here. Over here, we're going to have 180 degrees plus our reference angle. Over here, 360 minus our reference angle. Remember to use the answer button to bring all the decimals with you. So this should be 195.466 degrees. Over here, we should have 344.534 degrees. And these are our 2 answers. Now we can also do the same thing on the interval 0 to 2 pi. In other words, this means we have to solve it in radians. So it's the same series of steps, but on your calculator, make sure you set it to rad mode. Again, we isolate by moving the 0.8 over. So you get 3 sine x equals negative 0.8. Divide by 3. If your calculator doesn't do the nice fraction, you could leave it as 0.8 over 3. That's fine. So sine inverse of 0.8 over 3. Again, make sure you're set to rad mode. Let me see what I get on this. 0.8 divided by 3. 0.2699 dot 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 dot. Right, we really want to keep all those decimals, and this is our reference angle. We're looking for where sine is negative. That's here and here. Pi plus reference angle, 2 pi minus reference angle. So if we do pi plus answer, that will give us 3.41, it looks like 115, so rounds up to 2. 2 pi minus our reference angle, 6.013. Now you can write rad next to it if you want. Technically you don't have to write rads. You do have to put the degree symbol, but rads are assumed. But I always like to write rad just so I know what I'm doing. And so that's the basic steps when we have our calculator and we have things that are not unit circle values, right? 0.8 over 3 or the other fraction 4 over 15. That's not a value that shows up on the unit circle, and that's why we need our calculators. All right, now let's try something a little more interesting. We have 3 sine squared x minus 11 sine x minus 4 equals 0. And in this case, we're going to solve it in rads, so 0 to 2 pi. We're going to need a calculator. Now right away, we notice, because we have a sine squared, we're going to need to do some factoring here. We could go ahead and do it in algebra with a letter instead of the sign. But just be careful that you don't say something like let sine x equal x, because we already have the letter x in our question. So we'd probably have to say let sine x equal y. That's going to give us 3y squared minus 11y minus 4 equals 0. So we're looking for two numbers that multiply to give negative 12. Had to give negative 11. Looking like maybe negative 12 and positive 1. Yeah, that should work. So 3y squared minus 12y plus y minus 4. So that gives you 3y in common. Y minus 4. Here we have just a 1 as a placeholder, y minus 4. Factor out the y minus 4. 3y plus 1. That gives you y equals 4 and y equals negative 1/3. Now remember, this algebra step isn't the end because we weren't asked to solve for y, we were asked to solve for x. We have to find our angle. And so we need to sub back now and say sine x equals 4 and sine x equals negative 1/3. Both of these are like their own little mini problem. They're like the question we just did previously. Now, let's start with the sine x equals 4. In this case, we would do sine inverse of 4, but something interesting happens when you do this on a calculator. If you do sine inverse of 4, you should get error. And what's going on there? Why are we getting an error? Because if we try the other side, if we try sine inverse of 1/3, that's going to give us a number. Now the thing is, sine can only go as large as 1 or as small as negative 1. I mean, just think back to the graph of sine, right? It goes up and down. The highest value is 1, the lowest value is negative 1. So sine x equals 4 is sort of like saying, where does the sine graph equal 4 on this, right? Imagine 4 up here. Does it ever get to 4? The answer is obviously no. So if you ever have a number bigger than 1, anything bigger than 1, or anything less than negative 1, you're going to get no solution. This is true for both sine and cosine. And you'll know it's no solution because when you get on your calculator and you hit sine inverse, it'll give you an error. So as long as you're in the calculator section, you know that definitely this doesn't work. If you're in the no calculator section and you're asked, does this have a solution, yes or no? If the number is bigger than 1 or less than negative 1, you can say right away, no solution. But over here on this side, negative 1/3, yeah, that's between 1 and negative 1, that's fine. So we can go ahead and solve this like normal. We'll do sine inverse of 1/3, right? Drop in that negative sign. That's going to give us 0.339 and so on. Pop over here for our cast rule, looking for negative values for sine, pi plus reference angle, pi minus 2 pi minus reference angle. So pi plus answer, that'll be 3.481. Over here, 2 pi minus will be 5.943. Rad, and those are our two answers, so we can circle them up. So even though we had a quadratic, and in the end we get these two values of y, this one gave us two answers, but this one gave us no solution, and that's just sometimes what happens. All right, let's try this one. We have 2 tan squared theta minus 7 tan theta minus 4 equals 0. Well, again, we could do our little trick. Let x equal tan theta. So 2x squared minus 7x minus 4 equals 0. Looking for two numbers that multiply to give negative 8. Add to give negative 7. Looks like maybe negative 8 positive 1 again. Okay. Let's go ahead and factor that. 2x squared minus 8x plus x minus 4 equals 0. 2x in common, x minus 4. 1 in common, x minus 4. Take the x minus 4 out, 2x plus 1. Set each factor to 0, so x equals 4, x equals negative a half. And then, of course, go back to tan. So tan theta equals 4, tan theta equals negative a half. Now, in this case, when you do tan inverse of 4, you're not going to get an error because tan, unlike sine and cos, is allowed to take on any value. If you remember the quick sketch of tan, it's all the way down at negative infinity and all the way up at positive infinity. And then, of course, there's the asymptotes. So tan actually takes on any value, so there's no issues with tan. Okay, well, let's continue that one over here. Tan theta equals 4. Using our calculator, tan inverse of 4 gives us 1.325 and so on. The cast rule says tan is positive here and here. So this one is just our reference angle. So the first one here, make sure we round it though, 1.326. Then the other one is pi plus our reference angle. Again, use the full value on your calculator, 4.467. Okay, so we have two solutions from that portion. Then we have tan theta equals negative a half. So we do tan inverse of 1/2. That's going to give 0.463 and so on. Negative tan values, though, happen here and here. Pi minus reference angle, 2 pi minus reference angle. So we should get 2.678 and 5.820. So we've got these answers and these answers. So a total of 4 solutions here. All right, sine squared x plus 5 sine x minus 2 equals 0. So I'd encourage you to pause the video and give this one a try. See what you come up with. All right, so let's see how the factoring works. Again, because we already have an x, we'll have to do y. So we have y squared plus 5y minus 2 equals 0. Looking for two numbers that multiply to give negative 2 and add to give 5. Well, the only numbers that multiply to negative 2 are negative 2 and 1 or negative 1 and 2. Neither one of those add to 5. You might have got stuck here and said, well, how am I supposed to factor this? It doesn't seem like it's factorable. Well, if you remember, the way you check if something's factorable is you hit up the discriminant. B squared minus 4ac. So that'll be 5 squared minus 4 times 1 times negative 2. So 25 plus 8. Oh, well, that's going to be 33. That's positive. So it definitely factors, but we can't see the factors. And this is unfortunately that situation where it factors, yes, but it doesn't factor nicely. It factors using the quadratic formula. So now our step with algebra has gotten even more complicated. We have to take this quadratic and we have to apply the quadratic formula to it before we can even do any trig stuff. So again, I'd encourage you to pause the video, try to use the quadratic formula and see what you come up with for the two answers. All right, here we go. minus b, so minus 5, plus or minus the square root of, well, we know the discriminant already, it's 33, all over 2 times 1, which is 2. And so our two answers for y are y equals negative 5 plus root 33 over 2, and y equals negative 5 minus root 33 over 2. In other words, sine x equals negative 5 plus root 33 over 2. Sine x equals negative 5 minus root 33 over 2. Okay, well, I guess let's just continue on with these two answers here. This means we have to do sine inverse of negative 5 plus root 33 over 2. Well, actually, is that even is it a positive number? Is it a negative number? My goodness, this is pretty messy. So negative 5 plus root 33 over 2. As a decimal, it's 0.372 and so on. So it's a positive number, so you don't have to drop the negative. That's good news. When we do sine inverse of it, we get 0.381 and so on. So let's keep following the steps. The cast rule tells us we're looking for positive. So here and here. This will just be our reference angle, so 0.381. And then over here, we'll do pi minus our reference angle. So that should give us 2.760. All right, on to the other one. We have to do sine inverse of this mess. Now, when you go ahead and type that in, let's see what we get. Well, we could check if it's even negative, because we do like to drop the negative. So if we type it in without the sine inverse and do it on as a decimal, it gives us negative 5.372. Well, I mean, we could drop the negative, but really, we should see that there's a problem already. If we do sine inverse of the answer with the negative included, we're going to get an error. And that's because our number, negative 5.372, this thing is less than negative 1. So there's no solution. This is like that answer before where we had a 4. 4 is too big. It's bigger than 1. Negative 5.372 is too small. It's less than negative 1. So this branch of the question gives us no solution. So we have our two answers, and I think we're good to go. Let's go ahead and take some notes on this. So here we're solving, I maybe call it advanced trig equations. And again, the steps are still the same. It's just that we have really all the complexity. So first we have to use algebra to solve. Sometimes this means using the quadratic formula. And then we have to use trig. And this often means using our calculator and the cast rule. And we have to remember, of course, that for sine inverse, whatever is in here has to be between negative 1 and 1. The same is true for cos inverse. But for tan inverse, we could do anything. Right? If you get a number bigger than 1 or less than negative 1, you're going to get no solution. So I'll give you one that's pretty tough. We've got 6 cos squared x plus 2 cos x minus 3 equal to 0. And go ahead and solve that. I'd encourage you to pause the video and give it a try before I put the answer down. All right, assuming you gave it a try, you should have these as your values for x. 0.977, 2.675, 3.608, and 5.307. And you definitely need the quadratic formula for something like this. Now over here, we are doing Unit 6, Worksheet 7. So you can go ahead and choose your own question and then write down any things to remember. Now just one last thing I want to look at. This is kind of extra, but I want us to look at a question like this. 2 sine theta equals root 2, where theta ER. You might have seen this on some of the review questions or maybe on previous exams. We haven't talked about this a whole lot, and it's more just like a little extra thing we can tack on. It's nothing super new. It's just what's called the general solution. So what we do here is solve like normal. We divide by 2. So we get sine theta equals root 2 over 2. And then we solve this. So what are the values? This would be a unit circle question. So you could say theta equals pi over 4. And theta equals 3 pi over 4. Right, again, based on our cast rule. But because it says theta ER, it technically means that we're not looking just on the interval 0 to 2 pi. We're looking for all the values. And if we remember on the unit circle, right, we'd have this as one solution, but we could also imagine going all the way around and getting back here, right? That would still get us to the same location. So pi over 4, we could technically add 2 pi to it, and it would still be correct. We could even add, we could go around another time, right? We could imagine going around once, twice, 3 times. We could just keep going around and around and around, and as long as we end up at a pi over 4, this will be a solution. The unit circle has an infinite number of solutions on it. We just usually look for the solutions from 0 to 2 pi. But theta ER means, well, we're looking for all real numbers, any solution. So you could add 2 pi, you could add 4 pi. The way we write this is we say we could add 2 pi n. We could add any number of 2 pi's, right? N could be 1, 2, 3, 4, or n could even be negative numbers. -1, -2, -3, -4. N could be any positive or negative whole number, and we would still get a solution. So the way we write this is plus 2 pi n, where n, e, z. This symbol right here means the integers, or in other words, positive and negative whole numbers. And we write the same thing over here, 3 pi over 4 plus 2 pi n, where n is an integer. So whenever we're solving over the real numbers, it means we have to write the infinite number of solutions that exist, and we write that by putting a plus 2 pi n, and then stating that n, this extra variable we added, represents the positive and negative whole numbers. If you want more questions like this, these are technically called general solutions. And you can take a look on previous exams, or just go ahead and YouTube a video on general solutions for trig equations. It's not a huge topic, but it does come up now and then. Again, the basic idea here is just to add 2 pi n to the end of your solutions. All right, hopefully you enjoyed this video, and as always, thanks for watching.